So what we're learning about today is how we can use imaginary numbers to work with expressions when we have a negative square root. So if we turn our attention to the far right, we did a fantastic job at rationalizing the denominator here. However, we ended up with an expression that can't really be put into a scientific calculator unless, of course, it's got complex mode. Now, we've already looked at how we can convert the Casio calculators to be able to deal with these. Let's look at how we can convert ourselves to be able to deal with these. So if we have, what's your favorite number, Harrison?
7.
7. Your favorite square number?
64.
64. If we have, let's go 7 root negative 6. If we have root negative 7 times 64, we can simplify this. Firstly, what's the square root of 64?
8.
8. So we're going to have 8 squared times 7. And then, next to the times 7, what's missing off the 7?
The negative.
The negative. I'm going to write this as an imaginary number. To do this, what I'm going to do is I'm going to bring the 8 out the front, root 7, and then isolate the negative 1, because the square root of negative 1 has a special math symbol assigned to it. We call it I. So the I symbol means root negative 1. And to be honest, usually we write it as 8i root 7, but it doesn't matter too much, so long as we're careful with that radical symbol. So all of a sudden we have this way of being able to describe radicals that have a negative inside the radical symbol. So we call these imaginary numbers. Now this is really practical because all of a sudden, if we wanted to simplify this in a way that's using imaginary numbers, what would we say? We'd get rid of the negative 1 here and put I. Nice and simple.
Is it just 3 minus I?
3 minus I all divided by 5. How cool is that? So much simpler. All right, let's look at some application here. Suppose I have solve for the unknown A. We want to solve the equation x squared plus 1 equals 0. Firstly, what is our unknown? Don't be shy.
X.
X. But x is being affected by the square symbol. Where do our constants belong in equations? Which side, the left or the right? The right.
The constant.
Yeah, the constants belong on our right. Our unknowns belong on our left. So what do we need to move to the right first?
The 1.
The 1. Then, what do we need to do to find a singular value of x? I don't care about x squared, I care about x. I need to square root it. Hence, x squared is equal to the square root of negative 1. Does that make sense? Sorry, x is equal to the square root of negative 1. But do we have a way of describing this?
X equals I.
X equals I. Now there's one more thing that I left out here. If we square root something, what symbol do we need to put in front? Plus or minus. So x equals plus or minus I, or another way to do it is it's I or negative I. I think so. Is that cool? Okay, let's do another one. And then we're going to do something slightly different to where you'll start off in the textbook. Let's go. Let's say x squared plus 64 equal 0. What will this one be?
Is it just x equals a?
X equals a? What sort of a?
Oh, you move it over the outside, yeah.
Did you do it, Harrison? Or just doing it in your head?
In my head.
Right after you put the font.
So again, we move our constants to the right, we move our unknowns to the left, we remove the coefficients from the unknowns, but there are none, and then we square root at the very end to get our answer. If we have a negative inside the square root symbol, we simply express it as the negative turns into an I, and whatever you have there just turns into the square version of it. If you can't square it, then you just write it at the radical at the very end. Typically, I goes in front of the radical, but it goes behind any coefficient. Does that make sense, guys? Does this make sense on what we're doing?
Yes.
Okay, cool. This is solving equations. The other little bit is factorizing. Okay, if we have this guy over here, could we factorize this? Remember, what situation are we dealing with here? Don't be shy.
Dots.
Dots. Now, if we want to simplify, or sorry, factorize a dot situation over here, what rule do we employ? So dots is when you've got the difference of two square numbers.
Do you make the 9 into 3 squared?
Yeah, you make the 9 into a 3 squared. So the x can easily be square rooted and the square expressed there. And then the 9 turns into 3 squared. And then simply looking at that, you have a look at the rule up here. It's always going to be plus brackets, minus brackets. So first term plus second term times first term takes second term. Are we comfortable with this? Okay, one more just to make sure before I give you something mean. This one, I'm going to pick on you, Alyssa. Then I'm going to pick on Akifa. Then I'm going to pick on Harrison again. And then if I remember the order so far, we'll pick on Matilda, then Zoe, then Emma, and then Mia. And then it will be a random pick. What do you reckon the factorization of this one will be, Alyssa?
X squared. 5 squared.
Yep. X squared, take 5 squared. Oh, sorry. X squared, in brackets, take 5 squared. And then?
Then x plus 5. X take 5.
We all on the same page here? Excellent. Let's make things a little bit difficult now. We're going to use Z. We're going to go plus, and then finally, we're going to pick Akifa's favorite square number.
I'll just do 64 as well.
64. That's a smart choice. Okay. Is this still dotsable?
Yeah.
No.
Think about it.
No,
It's not negative.
because it's not negative.
It's not negative, is it? So I'm going to give you some gentle encouragement.
So you should do the exact same thing.
What will we put in here to make it negative?
Negative 64.
What's the dot?
64. 8.
8.
Negative 8.
Mm,
No, just A. It's a negative sign
what two numbers, or what number can you square to get positive 64? Sorry, negative 64 coming out of that bracket. Because remember, this is a positive.
there. 8.
So think about it. We're going to need two negatives to make this positive again. What are we going to put in here? Because if we go negative 8, we're going to get 64 coming out. It'll be z squared take 64. So what should we put in there? What sort of 8?
Negative 8.
Not quite. Almost negative. Half of the negative. My man. If we put the I in there, then when we square 8i, we're going to get what number?
Positive 64.
Not quite.
Negative 64.
Negative 64. And therefore, writing this in its fully factorized form, what are we going to write here? Z plus
8.
8i. Once more with confidence.
8.
Lowering intonation.
8.
Lowering.
Lower.
Start high, go low.
8.
8i.
8.
Bang. Bang. So if we expand that out, we get this expression here. Isn't that so cool? You can dots basically anything. Do you guys want to prove that you can dots basically anything?
Yeah.
Okay. Since we've done a nice example we all understand,
On the top window.
to finish this off, let's just do something I've never tried to do before.
Well, let's just hope.
It does.
I've got this. No distractions this lesson.
Okay.
Can we dots this?
Yes, you can.
Why not?
Square root of y squared.
Why doesn't this?
take,
And then square root of 5 squared. Genius.
what else do we need?
I.
Where did I go?
Do this last lesson.
You did the dog.
We did that last year.
Not like this.
Not like this.
Is that okay?
Yeah.
So this will look really confusing because we've never tried to do this with numbers before. Last year when you were factorizing, when you got it down into like z squared plus a number, that would have been perfectly fine, especially in your polynomials topic. You would have known that the zeros of example C would have been, what is it, plus or minus 8, I think. Would they? No, you wouldn't have been able to do C. Sorry, with B and A, you would have known that the zeros of that expression would have been plus or minus 5 for B and plus or minus 3 for minus 9. But now you're able to do it with imaginary roots, which is really fantastic because it opens so many doors. Alright, so what we're going to... Are there any questions? Yo,
When do you put the I in?
when?
Like, why do you put it?
Why do we put it in?
Because you've got negatives.
Because otherwise it wouldn't equal 5.
We don't ever express, so in the exam, or like the entry question, I gave you a negative square root. We never do that
Okay.
because it makes people scared. So
So-
instead,
You put that there because you've got the negative.
yeah. So if you ever deal with a situation where you need a negative radical, we always use I instead. It'll make a lot more sense in a few lessons time when we start working with complex numbers. So these are imaginary. Complex is when we add real numbers in the mix with imaginary numbers. It makes sense why we wouldn't do it with a negative there and why we do it like this. Simple. Alright, so what we have to work on, we're on learning intention 5. I got the solutions up today. Now you guys are going to start off with writing these in the convention of using imaginary numbers. So when you see the negative root 9, how might we write that? 9i. Next you need to write that as the product of linear factors. So for all of these here, all you're doing is you're going to use dots. So you use dots to factorize these. After that, we're solving equations. So move your constants to the right, variable terms to the left, apply the square root. The only ones to be very mindful of are these guys over here.
Okay.
Have a think about it when you get up to it. When you have a x to the power of 4, how many solutions will you get?
What did you say again? Sorry.
How many roots do you get on a 4th order polynomial?
4.
4. So if you have a 4th order equation, how many solutions will you get? 4.
4.
4.